dos, uno. Hi everyone, welcome back to the Constructs channel, Becoming a ROS Developer. My name is Rodrigo, and today we have a student that has completed one of our courses. It's a ROS Basics in 5 days for Python. So he's going to show us, his name is Mikel, he's going to show us what he did for the project that he had to finish for his course, which includes making it work in our real robots here at the Construct. So without further ado, welcome, Mikel. Thank you very much for coming, and how are you?
Hello, I'm fine.
Great. So whenever you want, you can start sharing your screen and just show us what you've done with your project.
Okay. Okay, I have
Great, we
shared
can see
now.
your screen.
Okay. So I will start first doing the demonstration of the real robot, and I will explain how does it work.
All right.
So my program is divided into terminals, in two parts, let's say. The first one is the action server, the launch that launches the action server. And the other is the launch that launches the main program, that is the service and the following script, the main script. So I launch the action server, and I launch the main. This launch file launches the service node and the main node, let's say.
Okay, and we can see it.
So now the robot is trying to find the wall, the closest.
All right.
This is the service.
Oh, looks like it found it.
And now
with
turns.
road.
So that's it. And now starts the action server and the wall following script. So every second the action server is sending the feedback of the total distance of the odometry. So here you have the printed in the console.
Great, and let me ask you, while this was doing the lab, why is there a reason why you have the action server separated from your main program?
No, there is no reason, just for the sake to be more clear, or yes, to make it more clear. Yeah.
Okay.
But it could be in one launch only and just launch everything together.
All right. Oh, looks like you.
So to count the total distance.
Mikel, can you hear me? It looks like we're having a little connection issues. Hello. Oh, it seems that we have. Oh, there we go. We got you back.
Okay.
Sorry, we froze. Your computer froze for a sec. So if you don't mind, let's just pick up. You can start sharing your screen again, and it was like almost done. Oh, there you go. We see it. We see it now.
Yeah, I was saying that the total lap is 6.5, more or less.
Okay.
And once the lap is done, the action server sends the result. In this case, is the state 3, which means that it succeed. The action server.
So it finished, and then you just called it again.
Okay, and the action server console sends the odometry data for that lap, let's say.
All right. So is this output because it already finished the lap?
Yeah, this is the result.
All right, that's what we missed. Okay. All right, great. Well, while this is finishing up, why don't you explain us a little bit of how this works in the code?
Okay, I will start from the main script, that is the wall follower.
Uh-huh.
Bueno, I started defining some definitions from moving forward, right, left, just the velocity, the linear velocity, and the angular velocity. And I will start from the beginning. So first, I put up the node, the world following node, and I call the service.
Mm-hmm.
And once the service is called, here is the function. First waits until the service is up, and then execute this service with the find wall service and the find wall dot SRV message that is here. So this is the service. For the service, here is defined the service with the service itself, and the subscriber for the laser scan, and the publisher for the velocity command of the Turtlebot. And this is how it works. Here I have the same functions for turn right and move forward, just moving.
And how
this
does
is
it
the callback.
detect the closest wall? What is it looking for?
This is the callback service that here is the main code.
Uh-huh.
And I have in two while loops. The first while just detects the closest wall, and the second while approaches to the wall and then aligns this with the road. So the first while, depending on when the road starts stopped, first checks for the right and left laser distance. So depending on the laser distance of each side, it will start turning to the right or the left.
All right, great.
And then once it's turning, if the front laser is the minimum laser beam of a range that I have defined, it's a 20 laser beams. So if the front laser, just one laser, is the minimum of the range, it means that the closest wall is there, is towards the wall. So then the first while breaks and starts from with the second.
Mm-hmm.
And the second one, first of all, the rod moves toward the wall, which passes the wall distance, that is 0.3, and then start turning to the left, so we can be aligned with the road. And it start turning right until the right beam is the same as the front. Is the minimum of the laser mean right, that is the range of the right laser, 20 laser beams. And once it's aligned, just breaks the while, and this is the service how it ends. It sends the true, the response well found, and it finishes.
Great. And let me just ask, how does it? So is the turn left function? I missed that. How does it know when to stop? Is it by time, or do you have a sleep, or is it what are you using it for? Because you're turning left and then it's stopping.
The turning left.
So when it aligns with the wall.
Yeah, I don't use it the minimum left. I don't use it. I started doing some tests and it doesn't work. So I just use the left laser beam to have the first measure. Let's say.
I see. Great, awesome. And then can we look at the action server?
Yep, the action server is here. Well, the main program, once the service is finished, waits 1 second and then calls to the action server.
Right. Okay.
And the action server is a class. Move to the class. So first, I define the feedback and the result messages that I will need later to give the feedback and the result.
Mm-hmm.
And the variables that will record from the odometry, the X position, the Y position, and the orientation. So the classes first I need the class, I need the action server with the record on action, and the dot action message, and then executes the callback. So the callback is here. First of all, I subscribe to the odometry. Here is the odometry. Takes the X, Y, and Z data, and it recorded in a 0.32 message type.
Mm-hmm.
And okay, vale. Then I start with the success in false and execute the main while the while loop. That is that if the total distance measured is less than the lab, that is 6.5, the robot start calculating the Euclidean distance of the
Right.
odometry using the x and y. And well, this is the distance how it is calculated. This function just checks for if the action is printed because some error or whatever.
Mm-hmm.
And here is the feedback. That is the total distance. That is sending it in 1 second to the wall following script. So when the total distance is bigger than the lab distance, the while breaks and it sends that is a succeed. Here is the true. And so sends the odometry data to the once it's finished.
Okay. Awesome. Uh, Great. So that's pretty clear. Let me ask you some questions.
Mhm.
So right now, we can see the robot is still moving. Is that because it hasn't received the action server success? Because I can see the output there
Mhm.
of the returning the odometry values, but
Mhm.
that didn't happen again. Why is that?
Yeah, because once the action server is finished, I didn't just code the stop function, so it keeps
It,
going around.
okay, okay, it keeps going on forever. So if we
Yeah,
were
yes,
to kill everything and then launch again, then it would do the one lap and then print it out.
yeah, it should.
Okay.
For example, starting from here.
Will probably take a while, but we'll see.
Mhm.
Okay, so then it just completes the lap, and at that moment, you get the results
Mhm.
and prints them out, and
Yeah,
then it just keeps going on forever.
for the perfect function, and maybe I should put the one stop function to stop the robot and start again. But
I mean, I wouldn't say perfect,
this is
but
how
for
I'm
your
gonna.
sake, once it's done. But yeah, I understand. I understand what it's
Yeah, once
doing.
it's done, it's okay for me.
I just was making sure that the action returned a success, which
Mhm.
I saw it in the output. So I just wanted to make sure why it happens, how it happens. All right,
Mhm.
then congratulations, Mikel. This is a really
Thank you.
simple, really straightforward project, and I liked how you created the every section very separated. Let me give you a couple of advice that I see from your code is
Mhm.
the so I understand that it doesn't make a difference having the action server separated from the main launch. Like
Mhm.
I get that. This is more of a because it's how I see a lot of people work and how I work and the common mistakes I make. And is
Mhm.
that when I can do that, when I can just put things um, in one launch, I do it because otherwise managing a bunch of terminals can get a little trickier. Now, this is great. What you're doing is great when you're debugging, I think, because you want to separate sort of all your processes in case you have an error to identify it. So,
Mhm.
but just so you know, that's a little bit because once you start getting more and more into it, you'll see that it can get to a nightmare in terms of launch files. So
Mhm.
that's one. And then the the other advice I have is I see in your files in your Python scripts
Mhm.
that you don't have a main function. You define your functions and all that, and then after that you don't have like if main equals blah blah blah, and then you put your main function, then you call that. Uh,
Mhm.
I think you should do that mainly because it's just good practice, and I don't know what problems will happen later down the line with more complicated programs, especially since a program like this will just go from top to bottom and then that's it, right? For things when you're trying to do different callbacks, things like that, it can get complicated. So I recommend just having a template and just pasting it every time. And but other than that, everything else is really nice and clear. Do you mind, Mikel, stopping sharing your screen so we can say goodbye here?
Of course. How would I do that? Because I
think there's a green arrow pointing up in your Zoom.
What? Here is okay. Okay.
All right. Okay. Cool. So yeah, congratulations. Other than that, I don't have any comments because it's very clear and you accomplished everything we asked for. Yeah, congratulations again.
Thank you. Thank you so much.
No problem. And we hope to see you in another course if you're trying to do more ROS learning.
Sure.
And just the same advice for everyone else that's watching. Here you can get a certificate if you show what you've learned in this kind of setup of presentations. We make sure that people get the key takeaways of our course. So if you're interested, you can do what Mikel did here. But other than that, thank you so much, Mikel, and we'll see you guys for the next video.
Bye-bye. See you.
Bye-bye, everyone.